Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is open the log. Let's go to LeetCode. All right. So you have a log in front of you with 4 circular wheels. I'm sure you have seen a log like that. How does it look? Let me show you how does it look. It looks like this. This right here. This is the log that we're trying to open. It has basically 4 wheels. These are the wheels, and you can rotate these wheels, and once you rotate them, you can rotate them up and down. They will change number. They will increase the number. If you go up, it might decrease the number, increase the number, like, you know, both ways. Then what are we gonna do? So basically each wheel has 10 slots, 0 to 9. Basically there are 10 numbers, and the wheel can rotate freely. We already talked about it. Freely, like up and down, from between 0 and 9 and 0, or 0 and 9, whatever. The log initially starts with a 0, 0, 0, 0. So for all the 4 digits, there's 0 right now. A string representing the state of 4 wheels. So initial state that's given to us is all 0. Now we are also given a list of dead ends. Dead ends are basically that combination where if we reach that combination, it will kind of like get stuck. Okay, so we don't want that combination. Now we need to avoid that combination. Now given a target is like basically the log that we set. If we reach target, the log is going to open. Representing the value of the wheels that will unlock the log. Return the minimum total number of turns. Turns is like, one turn is like out of all those 4 digits, basically moving one wheel up or down, that counts as 1 turn. Okay, so now we need to return the minimum number of turns that we need to open the log. All right, otherwise -1. We understand the problem. This is the log right here. It has 4 digits, 4 wheels. We can turn them up and down. So in one go, this 0 can become like basically 1, or it can become 9. All right, and that can happen with all these 4 digits. So for first example, we have basically the first state is 0, 0. This is my target. So we need to find minimum number of turns to get to our target without getting stuck with the dead ends. This problem, let's think about it. Let's say our initial state is this right here. This is our initial state. 0, 0, 0, and 0. And this is a string, by the way, right? So in one turn, what can I do? In one turn, if I choose basically the first digit to change, which is basically, in this case, it's right here, this one right here, I can actually make it either 0 to 9 or 1. So let's say I change it to 1 and 0, 0, 0. So that's one possibility, right? There is another possibility. I could have turned it up, so that would basically circle back to 9, right? So that would be this. So if I'm working on this digit, the first digit, that means I have 2 possibilities. How about the second digit? Well, that will also have 2 possibilities. What are those? This will remain 0, and then 1, 0, 0, and then same way 9, 0, 0. All right, and then I have basically if I work with the third digit, then also I have 2 possibilities. What is that? 0, 0, 1, 0, 0, 0, 9, 0. All right, and then there is one more. So we have worked with these three, and then this one. If we work with this one, so then also we have 2 possibilities. 0, 0, 0, 1, and then 0, 0, 0, 9. All right, so from this state, with one turn, we could go to all these 8 possibilities, right? 8 possibilities. So from here, with one turn, we could go till here, 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 and all of these. So basically, one turn can take us right there. But given that none of these states are deadlocks, and from these states we can go to multiple states, right? Like from here, then we'll have 2 possibilities, right? 2 possibilities. What are those 2 possibilities? They will be basically well, actually from here it's not 2 possibilities, sorry, there are 8 possibilities. 8 possibilities. Choosing first digit here, that gives me 2 possibilities. So for 4 digits it's like 8 different possibilities. So let's say if I work on this one, then I can make it like 2 0 0 0 0, and then there is another possibility. If I'm working with digit 1, then it's gonna be, you can decrement 1 to 0 again. So that's already like, it's gonna take you back to where you started. So now you see all these possibilities while working with each digit and changing the number up and down. So in this case, in all the possibilities, somewhere our target will exist, right? How do we reach our target? So right now you can imagine that like it becomes a graph, and now we need to do the best traversal to reach our answer quickly, and that is BFS. Why? Because BFS will allow you to explore all these states simultaneously. What does that mean? That means you'll be able to look at all of these in just one go while you are traversing one level. At the end of the day, this term means level. One turn means you can reach all these states. So that's one level. This is one level. All these states you can reach in one go. Then from here another level would be reaching this one. So one level, second level will be exploring these other possibilities, right? This is so clear, right? Like it's just, the answer is right in front of us. Super simple solution, super simple approach. So from here, what are we going to do? We will put this state into my queue, and then I'll start processing that, and then I'll process its neighbors, and then checking that they are not in my dead end, I will append them to my queue so that I can explore their neighbors in the next turn. All right, so this is going to be super simple. We'll have a queue. In the queue, first we will start with our initial state, and then we'll basically try to create these neighbors. We will have to create them. They don't exist. We will pick one index and then like convert that to integer, do plus minus 1, and then we will basically append back to our string and then check if that combo that we just created, is that our answer. If it is our answer, then that means we just return basically number of turns. Otherwise we basically append that to queue, given that it's not in my visited set, and also it's not in my dead ends. All right, so let's get into our answer. I think that was super clear. All right, let me change the view here. Let's go to our code editor. All right, so as I said, we're going to have our queue. Let's declare our queue. Queue will initially have one value, which is 0 0 0 0. That's our initial state. Then let's create these dead ends as like also like a set. Okay, so these dead ends, I'm just gonna call it dead end, whatever, set. Let's just provide dead ends. I'm gonna call it dead points. Okay, I'm just changing the name. I don't want to have the same variable name. Then we're gonna have a visited set. Visited set initially is gonna be this, and then we can start our BFS. So you know it's gonna be while loop. While queue is not empty, I'm gonna empty this queue into, I'm loading all the values like so that I can process them level by level. So I'm just pulling all the values to my queue, and then I'm assigning this queue again. I'm emptying it. All right, so at this point what can I do? I am gonna check for each node. So let's say what do you want to call it? You want to call it log? Let's call it node. For each node in this queue, I want to process all that node's possible neighbors that I will be creating. But before I do that, I want to check few things, that this node that I want to process, it's not in dead ends. If this is in dead ends, I want to continue. So if this node already a string, and this is a set of string that I just created in dead points, so if node in dead points, then I want to basically continue, right? What if this node actually is equals to my target? if let's say this node is equals to my target, I'll just return what? Return the number of turns, which we forgot to declare on the top. So return turns. Initially, what if, like in the beginning, we'll be processing all the zeros, and what if my target was 0? Then I am returning 0 as turn. Basically, I need 0 number of turns to basically unlock the lock. All right. Then is the main part, and here is the main part. What do? We're gonna pick each digit of this lock current state that we have. So right now, let's say we're processing the first one, 0, 0, 0, 0. So I want to basically choose each digit, and then increment and decrement by basically one by one, and then create another that combo and check it if it's not already in visited. And then if it's not in visited, then I will basically append that to my queue. And yeah, that's what we're going to do. So it might seem a little complicated, but I'm telling you it's not. So for I in range 4, right? Now let's pick our digits. So for I in range, let's pick our digit that will come from my node. So this digit at particular I, that will be my current digit. So digit is equals to, I'm gonna convert node I. All right, node I, just converted the digit. This digit I want to increment and decrement one by one. So I can say for D in range, or not in range, for D in 1, and I'm just calling it direction, right? Either up or down. Okay, so direction and -1. That's how we process, like in the grid, we have like those 4 direction, right? Like 1, 1, 1, 0, -1, 0, if you remember, like from the directions. I hope you're solving the whole graph series together, or some questions together. But then here, what I want to do, I want to create new digit using this digit. I'll be creating a new digit. That new digit will be digit plus D, right? This dr, let's call it dr, direction, either up or down. That's why I have +1 and -1. Now this new digit that you have, you basically picked it at the ith position in your node, the state. All right, it could be 0th, 1, 2, or 3. Now since you have like basically either have incremented or decremented, you want to place it right back there. So you can call it new lock combination. So new lock com, let's call it com, new lock com, and that will be node. So node, this node right here, basically that's like, we're going up till ith. Ith will be excluded because ith digit has been processed as a new digit, and then we will append that right there wherever it was taken from, and then just have more values, whatever was remaining after that. So you'll just say I plus one, and whatever has been. So now this new combination you have, this is the new combination that you have. So basically for each node you are creating 8 combinations. So 4 here, 4 into 2, basically choosing each digit. This is so great, like it just worked out so perfectly. So now what do we want to do? We have this new combination. Let's check if this new combination not in visited, then what do I want to do? And remember, our visited set was supposed to have this already. Okay, we forgot to add this because we are not adding this 0 0 like anywhere here on the top. So that is why visited has to have 0. All right, initially this is the initial state already visited. That's what we are working with in the beginning. Okay, so now what do we do? If this is not in visited, then what do you want to do? Append it to your main queue, main queue is this one, main queue dot append. What are you appending? You are appending the new comp. Okay, that's it. Once you're done appending, also because now you'll be visiting it, so we can add it to our visit so that we don't add it again. So visited dot add new comp. All right, at the end, once you come out of this for loop right here, you want to increment your turn. So you remember when we were like unloading all the values into this queue that we were going to process on one level. So after you are done processing just one layer of this is what I'm trying to say. Let me just show you right here. This is what I'm trying to say. So once you are done processing all of these neighbors which are on one level, this is what you're trying to do, right? Like you were basically going 4 times, so 1 2 3 4, and then each time plus minus, and then once you're done processing all these neighbors, then you increment your turn, right? Then you increment your turn. So let's increment our turn. Okay, we are gonna come back here and turns, right? Turns plus 1, and then finally yeah, if we ever found the target, we were going to return the turns. Otherwise, we're going to return -1. That's it. Let's zoom out, and here is our entire code. Let's bring it a little together. This is it. This little tiny cutie code. Okay, let's try to run it on our examples. There might be some typo, but we'll get through. Concatenate. You can only concatenate string. Yes, we forgot to convert this to a string. All right. Yeah, that's what I was talking about when I said like there might be some typo. Usually this occurs. There is this another thing right here that when we are doing this, we were supposed to have basically the mode, because it turns, right? Like we were supposed to have a mode. The reason is like there is nothing after 9 or 10, right? There is nothing after 9. It comes back to 0, and if you decrement from 0, then it doesn't go to -1, it goes to 9. Let's submit it. Pa. All right, so time complexity will be here. Well, what is the number of total number of combinations that we are going to try? Well, that will be for each digit we have 9 and then 10 digits that we can change, and for those 10 we have another 10, so it's like 100, and then 1000, and then 10,000. Is that 10,000? I think that's 10,000. Yeah. So basically we're gonna have 10,000 as a as the time complexity. For the first time we are having this, and it could be said like constant, I would say, and that's what will be space complexity also for our visit set. And I think that will be it. Let's yeah, this is an interesting time complexity. We can, if you follow that that theory of time complexity, it can go to 1. That means it's constant. All right, let's go back to AlgoYogi, mark this solved. See you guys later in the next problem. Bye bye.